Okay, so this is the second video for section 10.2. We just talked about the handshake theorem, which deals with degrees. So I'm going to go ahead and take this opportunity to introduce a subject that comes up in the homework for this section, and that is the idea of a degree sequence. So degree sequence is just the list of all the degrees for the vertices in a graph arranged in non-increasing order. So that'd be like from the largest down to the smallest. So here's an example of a graph right here. And I'm going to go around and I'm going to label the degrees, label the vertices by their degree. So this first vertex up here has a degree of 1. This one's got a degree of 3. This one down here in the corner, we count the loop twice. So 1, 2, 3, 4. And then this one's got a degree of 2. So the degree sequence for this graph would be from smallest or largest down to smallest, 4, 3, 2, 1. There we go. Now, by the handshake theorem we just learned, the sum of these numbers should be even. So if I sum up these degrees, I get 10. Even number, right. Now, what that means is that not every sequence of numbers, finite sequence, non-increasing of positive or at least non-negative integers, not every one of those is going to be like a possible degree sequence for a graph, because if it sums to an odd number, that would make it impossible. So, whoops, sorry. So there's a term here. A sequence is called graphic if there exists a graph with that degree sequence. So we're going to do a few examples over here. First of all, 4, 3, 2, 1 is graphic, as evidenced by the first example. If I did 4, 3, 3, 1, that one is not graphic, since sum is 11, which is an odd number, and that violates the handshake theorem. So there's no possible graph that has that degree sequence. Let's look at 4, 2, 1, 1, 1, 0. Let's figure out if that one is graphic. So to do this, we can just search for an example, right? I'm going to come over here, put this in the middle of my screen. All right, so trying to figure out if this is graphic. First of all, I'm going to figure out how many vertices would the graph need to have. How many numbers are in this list? Looks like 5. So I'm going to draw 5 vertices here. And now I'm going to attempt to make a graph on these 5 vertices that has this degree sequence. So first of all, I'm going to look at the bottom. I'm going to see that I have the number 0 in that list. That would mean that I need to have a vertex of degree 0, which means that it has no edges. So I'm going to select one of these. It doesn't matter which one. I'm going to pick this one right here and say that, let's say that has degree 0. I'm going to fill it in. Now that vertex there is locked in, and it can't have any edges going to or from it. So that one is kind of like out of the picture. It's determined, and we're done with it. So now let's jump back up to the top here. I need to have a vertex of degree 4. So with these 4 remaining vertices, I'm just going to pick one. I'm going to pick this one over here, this one right here, and I'm going to try to make this one have a degree of 4. So, whoops. One thing I can do is try to make this degree as big as possible. I can put edges connecting this vertex to every other vertex. So. All right, I'm just going with this, and we're going to see what happens. If I need to make changes later, I will. But so far, now I have a degree of 3 right there. Huh, okay, I don't have any more vertices to connect to. So if we were making a rule about this being a simple graph, then this wouldn't work. But I didn't make that rule, okay? This could be any graph. So one thing I can do is introduce like a loop or a multi-edge. So I'll show you how you can do this with a multi-edge, but you can also do it differently with a loop as well. So if I just introduce one multi-edge, so I'm going to put another edge between these two vertices. Now I have increased this degree up to 4. 1, 2, 3, 4. So let's lock that one in and label it. So that's got degree 4. All right, so now I'm just going to check to see what my other degrees are and make sure they're okay. And if I have a problem, I can erase and change this. But let's see, I think this is good because here I have a vertex of degree 2, and then these vertices both have degree 1. And this 4, 2, 1, 1, 0 matches my degree sequence. So that proves that just this one example proves that, I'll make that go away. There we go. This sequence is graphic. All right, cool. There's just a couple of examples. We're going to do a few more over here, but I'm going to do these ones in the form of exercises. So I think I'm just going to put this in a separate video. So come back in the next video for some exercises on degree sequences.